So this segment, how it is going to work is me, Arnold will speak about something and I'll be asking him questions with a point of view where I'll be thinking as I don't know anything from basics, and it will be just a conversation between me and Arnold revolving around some audio models. So over to you, Arnold.
Hey, hi, Aryan. Thank you so much for having me in your channel. Um, so I guess we had planned it long back, but due to whatever circumstances, we could not have it done properly. But I'm glad that finally we are here. But it's not that this is the only one time I'm going to be coming. So I'm hoping that we will have pretty much more conversations like this and probably have a good knowledge sharing, right? So, for your viewers to give a brief or a quick overview of my history in terms of career. So, I have done BTech in mechatronics engineering and then MTech in AI, and then I worked for 3 years in a startup called Kaizen Secure Voice, where I worked with the Android team in deploying we were more into audio. So I worked with ASR models and I am also into NLP, text intent classifications. And so we had also worked with the Android team to deploy the model, right? So we had a cloud server and Android device was actually, we had APIs built up and we had deployed a couple of AI models. And apart from that, we also took part in IIT Madras hackathon where we got the second place. So that was with respect to Android, right? And apart from that, the recent achievements. So of course, there are other people who are into the team, and I was also a part of that. So that was Vimosh 5G hackathon. So you already know a little bit of that. But I'll talk about that law enforcement probably in some other call. But in today's you know call, what in a conversation. So what I thought was, why not go with a bit of basics, right? I'm not going to talk anything in depth of architectures. I want to keep this conversation quite basic, right? Even a person with the mindset of first year or second year who's coming into your channel and trying to look at these basic AI models. So from broader perspective, I want them to understand the terms like what is a pre-training, why is it done, right? What is fine tuning, and what are the advantages? And with respect to audio, so when you look at diagrammatical level, from a diagram perspective, so how are these ASM models, right from Kaldi? Kaldi is one of the most oldest, toolkit to build ASM models, right? So we'll be talking about a lot of these things. Can you please give me the permission to share the screen?
Oh, yeah.
I have a very tiny PPT, so we can just talk about that.
I- But I think you have.
Did you give? Yeah, I got the permission. All right. Okay. So what do we have here? Okay. So yeah, I just called randomly the name as AI Talks with Arnold. So basically, it's your channel. So it's just the name AI Talks with Arnold. Okay. So all right. So before getting into so today's agenda would be I would want to love to talk about pre-training in LLM large language models. And apart from that, I'll also try to touch up a bit with ASR, that is Whisper and Kaldi, these two things. And I'm not going to talk a lot of technical because it might be out of scope for students who are getting into your channel and trying to, understand. So it's been going to be a lot more general and basic conversations, right? Rather than understanding the topics, right? That would be the main motive. So first one, before we get into training and all of that stuff, so basic, some one slide on basics, like what is we all know what a data is, we all know what a data is, but inside when you talk about training, there's something called as labeled and unlabeled data. Okay, so any students who are getting in and who don't know these terms, so if you look at the picture, you see there are pictures of cats and dog, right? And in the left side there's something called as labeled. That means you have a label given, right? You're trying to tell the machine that look, this picture, this is cat, and this picture, this is dog, right? And in unlabeled data, you don't have anything. There's no label. It's just pictures. That's it. Okay. So these two terms are quite important for this as we move ahead. So label is you have given a target value for a picture or a textual data or whatever data it is or a video data, anything. And in unlabeled, it's like just there's a data. There's no target value for it, right? That makes sense. And I hope you got it, right? You already know, you're all aware of it. Okay. So now this is something. Now let's go to the basics. Now you know GPT. That's generative pre-trained transformer. And GPT has, especially the Chat GPT which came in, which made a lot of noise, right? Now I want to. There are two things here. One is pre-training, and another one is something called as fine tuning. Okay, so these two are quite important parameters. And even when I was working in the startup, I had got an opportunity to work to do the pre-training and fine tuning for the Indian languages. Okay, but before that, let's try to understand. So in a pre-training, what happens is we take a huge amount of data, like probably billions of lines of data. For example, you can take up English. Okay.
Right.
Now, in pre-training segment, it's a unlabeled, like it's unsupervised. Okay, we can talk about supervised. Supervised in the sense, you are telling the machine that this is the label, right? Like it's a
Yeah.
supervised. You're supervised. You're supervising a machine and telling that, okay, look, this is cat, this is dog, this is how you have to learn it, right? In unsupervised, there are no labels. Okay. So
Okay.
what is unsupervised pre-training? So what happens here is, suppose let's say you take huge sentences. Suppose let's say 1 billion rows of sentences. It's all English, okay? It's not a multilingual. It's all English, right?
All right.
So suppose let's say the first sentence is "Hello, how are you?" The first sentence out of that 1 billion, and what happens is "Hello, how are," and "you" is masked, right?
Mm-hmm.
Mask in the sense you're not going to show that to the
Yeah.
system while training, right? So in pre-training, what happens is the model is trying to predict looking at n numbers, right? N numbers. Hello, how are? It's trying to predict you. Okay. Sometimes it does mistakes. Okay. If there's a mistake, it goes back, looks at the loss function. That's a lot of again technical, but again comes back and tries to correct it. Okay. So now, what exactly is happening here? So there are again two varieties here. One is, causal language modeling. One is masked language modeling. Okay, causal in the sense, for example, hello, how are, and the next one is masked. You are trying to predict the next one. Okay, in
Okay.
MLM, that is masked language modeling, what happens is, hello, how is masked? Are you? So in between words are masked, right? MLM. Okay,
Yeah.
so now what happens is MLM is most effective to understand the context, right? So what is a context? For example, given a sentence, randomly you remove middle the words from the middle. Okay, you're just masking
Okay.
it. You're expecting the model to come out and give the prediction. So here what happens is contextually your model is brilliantly understanding the language. So basically, what happens after pre-training is your model is brilliant in English. You give any sentence, you mask it, it knows the next word. So contextually, it has learned English in a much much better way. Okay. For example, now you can see the input here. A robot must, right? Now the words are chopped into tokens, right? A is one token, robot is one token, must is one token, and next word it's trying to predict, right? So, for
Okay.
example, now based on the data, so it's trying to tell that the next word is exterminate, right? But actually,
Right.
the actual label is obey. A robot must obey, right? Now, based on data, it has learned exterminate and it's trying to predict it, right? Now, again, you calculate the error, go back and again update the model, right?
Oh,
Now,
all
this
right. I
is
have a doubt
how a
here.
pre-training,
I,
yeah,
I, I have a doubt. When we say unsupervised, it basically means uh, we don't have labels, right?
makes sense, yeah.
And now you are saying that model will predict something,
Mhm.
but will calculate error based upon what the label data is and what it has predicted.
Yep.
So how do we have label if it is an unsupervised model?
Okay. Now, why am I telling this using the word unsupervised? Because model is going to learn on in itself. Okay. Now I'll tell you how. I told you I took an example of hello, how are you? Right. Now there is no target label for that. It's just a sentence. Okay. Now what is the motive here for us? The motive here is the model should understand the context of English. Okay? That's the whole motive. After pre-training, what do we need? We need a model which will understand English. That's it. Okay. So
Right,
what is the way the it's going to, I mean, what is the way to train model which will understand English context? So it's like you take you take a sentence, mask random words in between, or you want to mask it at the end, mask it up. Okay, mask in the sense you're not showing that. Okay. Now remember, each and every sentence, human did not label it. It's just sentences. Makes sense.
yeah,
Okay. We just masked it randomly. It's random masking. Okay.
yeah,
So once the masking is done randomly, so you know that labels have been, the labels are the ones which are masked. Makes sense.
right,
Humans
right,
are not coming and labeling it, right? We don't have any target
yeah,
label,
yeah.
right? To achieve that task, it's automatically unsupervised. That means existing data, it's trying to do the masking and then trying to learn. So by this method of training, the model understands the context.
So basically, based on data, like we are seeing this is unsupervised based on data because we don't have a label for it.
You
But
don't have target, right?
yeah, but training that is happening is basically supervised training because
Yeah. The
yeah,
moment you do that masking and stuff, so that's where you're trying to manipulate the
right,
data and self-learn, right?
got it,
Unsupervised.
got it.
That makes sense.
Yeah,
Yeah. So let me go back to the one where I was working. So there we were trying to target the Indian languages. Okay, and we were supposed to scrape the data of Kannada wherever online resources were available. We had done that. We removed the Kannada data, and here for pre-training, what do we need? We just need sentences. There's no target. I'm not doing anything. It's just sentences we need. And what we did was we actually randomly, first of all, we did word level tokenization. We're not going to do character level and stuff. Okay, we did word level tokenization, and more the data, more better is your model. That's the code, because you want the model to understand the context of the language, right? So more the data you give, more better it is, with different word combinations, etc., etc. So we had taken Kannada, we had masked the random words, that is MLM, that's something called as language modeling, masked language modeling. We removed Kannada. Now what we did was, the data was quite huge, right? Approximately, I don't remember, it was some lakhs of lines. Okay. So after, so there was, for one epoch it was taking probably 16-24 hours just for one epoch, but we had steps in between, like step after 30 steps, 40 steps, or something like that. Okay. So what we did was we wanted to understand, like, how is this actually learning, right? So what we did was, in Kannada, what we gave was, Nano Bangalore. So in English translation is, I am going to, that's it. The last word is master. It's Bangalore
yeah,
actually.
yeah, yeah.
Okay. So after a few steps, okay, for example, around 30 40 steps. Okay. Step one, which has one, x amount of data getting in. Okay. After, it did not even complete one epoch. After, right, after steps of around 200 something, we try to get the prediction. You know that model will be saved intermediately, so we try to get the predictions, and we saw that, in Kannada, it was Nanu. What was the sentence I said? Last one.
I'm going
I am
somewhere.
going to. Yeah, I am going to. So instead of predicting a place name, it was predicting some random word. Some random
Right.
word. For example, country, or going, or some random words. Okay.
Yeah.
And then after 250, then we went to 500.
Okay.
Okay. Now slowly the model is trying to come to country names, or
Okay.
some place name, right? And
Yeah.
then another after complete one epoch, since the data was huge, it was not perfect, but to a range. The top predictions were the place names. Top predictions like 92% it's Bangalore,
All
and the
right.
rest 6% is right. So what you are actually looking at this is like through this method, your model is brilliantly understanding the language. Given one four set of words, what is the probability that next is this word, right? So pre-training is all of that, making your model understand the language contextually, right? So
Right.
I mean, I remember doing it for Canada, right? Now, once okay, now what? Now we are at the pre-training stage, you know. So once we are done with pre-training, you have a model. Like you can literally imagine a model, AI model, which can brilliantly understand Marathi, which can brilliantly understand Hindi or English or whatever. Okay. Now, next comes the fine tuning. Now, you look at these diagrams, which are quite interesting, right? So, LLM at the pre training stage, you look at the word large unlabeled data set.
Yeah.
The word large makes a lot of sense because the moment you take only 100 lines or 1,000 lines of English sentence, it's not going to learn nothing. In fact, I guess it's going to go learn only those probably overfitting, just learning all of those 1,000 sentences, right? And it doesn't know anything apart from those 1,000 sentences. It's not domain specific.
And
Okay.
when
It's
we say large data, I know we can't get an accurate number of lines, but what is the approximate range which can be classified into large data set? An approximate
I
range.
mean, there is, I mean, at the end of the day, the word would be like as large as possible,
All
right?
right.
So, and another thing, the moment you use the word large, you have to use a lot of domains as well: finance, banking, and education, and then general news, and then etc. 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 Right? So you cannot only bring finance 1 lakh lines and tell, okay, train it, right? So now your model is going to be more specific to only finance, nothing apart from that, right? So we want
Yeah.
to have large different domain sentences getting in, right? So now your model is pretty much knows different domains and the context, right? Now, remember the top companies like Google, Microsoft, and uh, whatever startups are there who have good resources to GPU, they are the ones who are more into all of these things. They actually try to give you the pre-trained models which are brilliant in understanding language because the small startups cannot afford to get
Yeah.
this because it takes like we need around 30 to 40 GPUs parallelly running for a huge amount of data set, right?
Yeah.
Now, a couple of them are open source. For example, BERT, which knows English, right? BERT also you have base, large, and whatever models you want,
Distil.
right? So now, what is the advantage for the small startups when you open source the large model, which knows English very well? So now these people, you know what they do? They take a very small data set. Now they know that this model understands English. They start fine tuning it for finance, banking only, banking chatbot, right?
Okay.
Or HR based interview chatbot, right? They know that this understands English pretty much well and it's very quick. So this is something called as fine tuning, right?
Fine
Now in
tuning
this
method.
fine tuning, we need a label data set,
Yeah.
right? Because you are taking a big large model and trying to show one path that it has to follow that, right? Provided it knows very good English. Can you hear me? I just
Yeah.
lost you.
Yeah.
So what I was trying to tell is that's what small label data sets. It's like you're specifically fine tuning it for a particular domain, right? That's the whole motive. Okay, and it's you can see it's computationally demanding. As I said, there's a lot of huge amount of GPUs which are required, but when you come to inexpensive, it's like very small data set. It's quickly training, right?
Right.
That's the whole thing.
All right.
Yeah. So if you look at this one, so of course, it's a multimodal LLM, but my focus is on the right part, right part of the screen, right? Text summarization, language translation, sentiment analysis, all of this comes under fine tuning, right? So fine tuning for a particular work, right? A small data set, and you can fine tune it. Okay. Okay, okay. Now it's that was all about LLMs, large language models, and if I compare this to ChatGPT, so what they did was first they pre-trained the ChatGPT and then came down and fine-tuned it on a chat-based data set, right? Of
Uh-huh.
course, the domain is quite huge,
All
so
right.
they have fine-tuned it on a chat-based data set.
All
Okay.
right.
Now, so this is all about textual part. Okay. Now let's come to interesting audio part. Okay. Now again, I'm going to talk about ASR, that is
Before
automatic speech
we move into
recognition
this,
system.
before we move into this, if you know that ChatGPT 4 has
Yeah.
this option where it can personalize as a tutor or something.
Yes.
So is that fine tuning
Yes,
that?
it is fine tuning. So they have a backend model, ready-made framework where you just give a particular instructions. So it's basically instructions based fine tuning model, right? It's not a data based fine tuning. It's more over instruction based fine tuning, right? So you don't need data, but just give instructions and it knows very well. So in that way, right? Okay, now let's move on to final topic. I'll not take a lot of time. I guess it's already okay. So let's talk about ASR, right? This is the basics of ASR. So ASR is automatic speech recognition system, and it converts the speech into text. Okay. Now what you can see on the screen is first this one is a audio frame, audio waveform, right? This is a sentence, like the
Translate.
sentence level. You see this is a word level, okay? And you see the last one, that is very important. That's something called as phonemes, right? Whatever we talk, a word is cut down into phonemes. Okay?
Right.
Phoneme is the building blocks of a word. Okay? So for example, this, what you can see this, right? DH, it's the smallest element. D is,
The
right? That's how
right.
you cut it. Right?
Yeah.
And similarly for ease, is, right? Is
Right.
a,
Right.
and then
Is
sentence,
uh,
and t, and okay,
makes
something like that. That's
sense.
how you cut it. So in Kaldi, what happens is, see, first of all, we are trying to predict the sentence. We are not predicting phonemes. Okay, of course, we come from phoneme to word, and then word to we join it to a sentence. Okay, so
Yeah.
in Kaldi, what happens? Kaldi is one of the most oldest toolkit. If you go and search in Google, Kaldi is one of the most oldest, but extensively used. Okay, so Kaldi uses phoneme level mapping. So what happens is how much number of seconds was the word this spoken by the user, right?
Right.
And inside this, it's already again cut into three pieces. Right? This, right? So Kaldi does this the mapping, like phoneme level mapping, and tries to train there is something called as HMM, GMM, HMM models, right? And apart from that, now we are also using now deep neural networks, using there's something called as TDNN. I don't remember the full form now, but yeah, there's something called as time dependent something, right? TDNN neural network. So yeah, so this is the basics of ASR, right? Right now we have direct character mapping. Character in the sense, this is again cut into THIS,
Yeah.
right? That's
Yeah.
character level,
Right.
and this is the phoneme level, right? So
Right.
we do phoneme level mapping in Kaldi. So this is the basics, right? So once the model predicts DH, IH, and S, and then
Okay.
they take the combination of these three phonemes, DH, IH, and S, and see which is the nearest word to this. That is this THIS,
Uh,
and then
all
they do the
right.
mapping. That's how
Just a
you
second.
go out of it.
All right. All right.
Okay, so that's the phoneme level mapping. Okay, now that's what is used in Kaldi. But let's come to the very recent one, something called as Whisper, right? And you
Okay.
might have heard of it. So Transformers got into. I mean, it's right now. I feel the Transformers
So just
era.
for our viewers,
Before it was
ASR
LSTMs,
stands for
automatic speech
automatic
recognition
speech
system.
recognition. All right.
It is something called as speech to text. The other way around, speech to text. That's how you tell
Works.
it. So we were using. They were using transformers. So once the Whisper came out by OpenAI again, now what happened was this was the best that time. Like when Whisper came out, like too good. Nothing could beat Whisper. They literally in the research paper you go and see, they claim that this is the best. Okay, of course, I don't want to talk about how did they train. We can have a separate session for that. But you can, if you can see, I want to focus. My more focus is on neural network. Okay, there's something called as encoder model. You can see a transformer encoder blocks, and in the right side you have decoder encoder blocks. Okay, now there were three to four varieties of whisper: small, base, small, medium, and large. Okay, so what they did was base was with little bit less in terms of layers. Okay, that's why it was around 300 MB, I guess. When you go to large, it is like 3.6 GB. Like, and large model is the best. It gives tries to give the punctuations, difficult words. For example, words like Indian names like Sakhala, Aryan, which
Right.
small model couldn't predict well, but this large model was doing it well. But now the challenge is, if you take a 30 seconds audio and try to decode using small model, let's say it's taking 10 seconds. Okay,
Yeah.
but the large model is taking 2 minutes. Why? Because the audio waveform, the log spectrum has to pass through all of so many layers, whatever it is, 26, 30, 40, 50
Yeah.
layers, whatever it is, right? And it's taking a lot of time. Now, when it comes to a real practical application where startups want to use it or companies want to use it, doesn't make sense. You cannot expect a user to wait for 30 seconds audio, wait for 2 minutes and come to and make the machine understand, right?
Right.
Now, any model which comes out to the market, it has its own challenges, right? And one more interesting way they try to solve this is something called as Distil Whisper, right? So this was a very brilliant mechanism how they try
Right.
to make try to reduce that time of uh, output without touching the accuracy or without degrading the accuracy, right? So what they did was they kept the encoder block. So encoder blocks understands the audio features very well. Okay, it's pretty much it encodes and gives the features, but decoder block is more over like sequence mapping. Right? This THIS sequence it maps the audio frame to the output, right? So now what happened was the brilliant work what they did was, suppose they say in decoder blocks there were 20 layers. What they did was they tried to keep the first layer and the last layer and remove all the between 18 layers, like literally, and just connected the first and the last layer. But remember, they did not touch the encoder, which was giving brilliant features. Okay, they did not touch that. They just took the decoder block and they tried to fine tune it again. Like fine tune it, only you train the decoder blocks, right? They don't touch that. And then what happened was they saw that and they literally lock all the other layers. They don't want to train it, right?
All right.
And they just open up the two layers, and then you see that there's a training is quite fast. It's quite
Okay.
fast, right?
Okay.
Because you are not traversing through all of the layers,
Yeah.
right? So it's only the two layers which you're trying to focus on towards. So this now I guess I'll talk about the same pre-training. I was talking about pre-training technique where
Yeah.
you give
Yeah.
5 words and you're trying to predict the next one, right? But I would also, but your question is, Arnold, you can do this for audio, you can do this for text, but there's one more important parameter called facial. Can we do it? The answer is actually yes. They have actually done that. I'll talk about it in the next some session because it's again too much in depth, right?
All right,
So
all
what they
right.
do is they cut the faces into 9 pieces, only the face, and mask some places on the face. And the model is trying to look at all the other parts of the face and try to predict
Oh,
what was the eyes movement and eyebrow, whatever, right? But yeah, the fundamental concept is this one. Why pre-training? Because you are making the model understand something, right? That is important,
yeah.
right? But yeah, so